Hi, this is Rebecca, and I'm going to go over Physics 1 free response problem. But first, what I didn't understand before the test was the relationship between acceleration, velocity, and position graphs, and also using kinematics formulas to solve problems. So basically, I chose a free response problem that dealt with both of these issues, so I can better understand what I missed on the test. So the problem reads, a half-kilogram car moves on a straight horizontal track. The graph of velocity v of x versus time t for the car is given below. So we can see this graph. For now, ignore the blue lines and that I drew and just focus on the black ones. So part A reads, indicate every time t for which the car is at rest. So since this is a velocity time graph, we know that when the velocity is 0, that means our car is at rest. So we look at the graph and the x-intercepts at 4 and 18. But we have to keep in mind that if this was an acceleration graph, an acceleration of 0 does not necessarily mean that we're at rest. Part B says indicate every time interval for which the speed, magnitude, velocity of the car is increasing. So this one's a little tricky, and the main thing we need to understand for this one is that speed is different than velocity. Velocity is a vector, so velocity has an amount and direction. So, for example, this can go negative, so our velocity goes into the negative area, but speed can't go negative. So we basically just took the absolute value of velocity, so put everything above the x-axis up here, and that is our speed graph in blue. So then we know that we have to look for when the speed is increasing, so that would be from 4 to 9, and then again from 18 to 20. And then part C was the trickiest part, and that says, determine the horizontal position of the car at t equals 9 seconds if the car is located at x equals 2 meters at t equals 0. So first we kind of have to look at what we have, so I moved on to another piece of paper here. So we want to focus first on this part. So we're trying to find our final position of x when our time is 9 seconds. We know that initially the position was 2 meters at 0 seconds. And we also know our initial velocity from the graph is 0.8 meters per second. And then we know our acceleration is negative 2 meters per second. And I just did that so how to find acceleration? Basically, we want the slope, and I chose 2 points because we're calculating to 9 seconds, which is right here. So from 0 all the way down here to from 0.8 to -1, and then our x goes from 0 to 9. So we want to find our slope of that because we know slope of a velocity graph is the same thing as acceleration. So we found that our acceleration is negative 0.2 meters per second squared. So now I went up here and used the graph final position equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. So now we plugged in all of our variables that we had over here into this equation, simplify the calculator, and then solve, and we should get x equals 1.1 meters. And this actually makes sense because you might think, well, we started at 2, how do we go backwards? But if we know our acceleration and our velocity from the graph is going downwards, and our acceleration, so we should be moving in a negative direction. So it makes sense that our final position is less than our initial position. I hope this helped clarify any questions about acceleration, velocity, and position graphs. And this is a 2000 AP free response problem. Thank you.